Rational numbers. Notice rational numbers, the word rational is underlined ratio. Rational numbers would be like numbers that you could express as a ratio. Ratio looks like a fraction, but a ratio is special. It's a subset of a fraction. How do you explain this to your students? Well, you can use a bar. Notice that first one is 1/3. The second one is 2/3. And the third one is 3/5. In other words, for the bar, it's 1 out of the 3 is shaded. For the number line, 2 of the units out of the 3 are shaded. And for the 5 circles, 3 of the 5 circles are shaded. So 3/5, 2/3, and 1/3. A rational number has to meet certain criteria. For a fraction-looking thing to be called a rational number, the numerator has to be an integer and the denominator has to be an integer. And remember, when you have a division and there's variables involved, make sure that you specify that the denominator can never be 0. We saw that some time back. Is 3 1/2 a rational number? Well, at first it seems like it's not. We're supposed to have an integer over an integer, but if you simplify 3 1/2, you could rewrite it as 7/2. And notice you have an integer over an integer. And of course, 2 doesn't equal 0, so it's okay. Yes, 3 1/2 is a rational number. Equivalent fractions, all it means is that you could write fractions a different way. For example, 4/8 would be the same thing as 1/2. They don't look the same, but they represent the same quantity. So yes, 4/8 equals 1/2. 4/8 is equivalent to 1/2. What I did was divide the 4 by a 4 and the 8 by a 4. I divided the top and the bottom by the same number to reduce it. Simplest form, 4/8 is not in simplest form. One way you could describe simplest form is saying that until the GCD of those two numbers, the numerator and denominator, is 1. In other words, when the GCD of 4 and 8 is 1, it's saying that there's no other number that can divide both of them. In other words, you've reduced it. But we know that we could divide the 4 by a 2 and an 8 by a 2. Therefore, 4/8 is not in simplest form yet, so you reduce it to 2/4. But even then, you could still divide the 2 by a 2 and the 4 by a 2, so you keep going until you get a 1/2. Now you can't divide the 1 or the 2. You could only divide them by a 1. So you reached the GCD of 1 and 2 equals 1. So 1/2 is the simplest form. So let's write this one in simplest form. This looks like an algebraic expression. What you do, since it looks pretty congested, break it up into 3 columns. One column has the constants, the numbers. The second column has one type of letter, and the last one type of letter, which are the variables, right? The letter variable. Take a section at a time. So 28/42, reduce it, and you get a 2/3. A over A to the second, reduce it, you get 1/A. And B squared over B squared, that reduces to 1/1. So at the end, you write 2/3A. Now we're going to compare fractions. And when we say you're comparing something in math, what you're saying is, are you going to insert a less than, greater than, or equal? So compare 2/3 to 5/7. How do they compare? Which one's bigger, which one's smaller, are they equal? All you need to do is cross multiply. Notice 7 times 2 gives you a 14, and 3 times 5 gives you a 15. And whatever you say about the 14 and the 15, that's what we're going to say about the 2/3 and the 5/7. Since 14 is less than 15, we could say that 2/3 is less than 5/7. Denseness of rational numbers. The idea of denseness, it's a weird word. All it means is, can you find another number between the two numbers that were mentioned? What does that mean? Are the integers dense? Are the integers dense? Well, pick any two integers, let's say 0 and 1. Can you find another integer between 0 and 1? The answer is no. You cannot find another integer. Therefore, the integer, the set of integers, is not dense. In this case, we're working with rational numbers. These are not integers anymore. This belongs to the group of numbers we call rational numbers, ratios, right? So how do you find, if you could find a number between two other numbers, how would you do it? In this case, we're working with rational numbers. Well, you could increase the denominator. Notice we have a 4 for each of them. We'll just up it to an 8. Just make sure that what you do to the bottom, the denominator, you do to the top, the numerator. So I'm going to multiply the 2/4 in the top by a 2, in the bottom by a 2. Also with the 3 and the 4, I get an 8, right? And you might say, well, why did we go from 4 to 8? They were already like denominators, but notice if you keep the 4, what number goes between 2/4 and 3/4? It seems like we're not skipping anything here. So what you do is you make the denominator bigger, and what happens, now you have 4/8 and 6/8. In between, you could have the 5/8. So now you found a number between 2/4 and 3/4. It's 5/8. So what is the thing that you need to remember? Just make the denominator bigger and then search for that middle number. Here's another method, and this is like a formula, but it's real simple, very, very simple. You don't do anything to the fractions they give you. You have 2/4 and 3/4. I don't do anything to them. I just add the top 2, and I put it here in the numerator. At the bottom 2, put in the denominator. Simplify. 2 plus 3 is 5. 4 plus 4 is 8. And this is the number between 2/4 and 3/4.